I'll go ahead and record this with the explanation again. So here's our truck. We have to go 440 miles. We usually do it in 8 hours. At the 120 mile mark, we realize that we're 0.25 hours or 15 minutes over. So normally, at that point, what time would it be? Well, if I use V as x over t and solve it for t, I can take x2, which is 120 miles, divide it by the average velocity, which is normally 55 miles per hour, and then I will get my time that I should normally be there. When I add 0.25 hours, I get that it took us 2.43 hours to get to 120 miles. So now all I have to do is subtract the distance, subtract the time, and then take the average of those two things. Take the average velocity of that section, which is just that mileage divided by those many hours. And once I divide them, I get my answer. Now, this time I'll record. Okay, so following my own whatever commands, I will try to use givens and all that stuff. So, all right, so there is acceleration is 400 Gs. In order to make life easy on myself, I'm just going to use G as 10, and then that way I can just say my acceleration is 4,000 meters per second squared. And it exerts itself over a distance of 0.60 centimeters, which is a distance of 0.0060 meters, I believe, yes? Because 0.6 centimeters should be 6 millimeters. All right. So, assuming the beetle jumps straight up, at what speed does it leave the ground? All right. So then, are there any hiddens? Yes. V0 equals 0. Okay. Right? So using alphabet soup, right? Some of these formulas are not like the other, right? You gotta go through and look and see what formulas match and choose the right one. So I choose this one. I choose you because it matches. So then now I isolate, right? And all I need to do is say VF is equal to the square root of V0 squared plus 2AX. Now, luckily, V0 is 0. So that goes away. So I get VF is equal to the square root of 2AX, right? So we've got 2 times 4,000 meters per second squared times 0.0060 meters. So if I go 1,000 here, I go 1,000 there, that's 2448, and then the square root of 48 should be like 6 point something. What is that? 6.84? Is that what everybody got? 6.84 meters per second. Questions? Okay. For B, when you are deriving another part of the question, if you can use the given information, that's always better. Because if you made a mistake in part A and then didn't get it right, then you'll lose points. Now, the nice thing on the college board usually is if you got part A wrong, but you did part B based on part A, and part B was correct based on the wrong answer from A, then you'll still get the full points. Now, let me ask you this. What does that mean about how you take the test? All right, so using the things then, if I say this is the acceleration, if I say this is the distance, and I want the time, knowing I have an initial velocity of 0, I'm going to say x equals v0t plus 1/2 at squared. This goes away, so t is the square root of 2x over a. So that becomes 2 times 0.0060 meters over 4,000 meters per second squared. And when you plug all that in, what do you get? You're going to get some really tiny number. 0.00171. Is that what you guys got? Seconds? Anyone? Okay, cool. All right, finally, C, how high would you go? This one, yet now we have to use the final velocity that we just calculated. So then our final velocity for part A is going to become our initial velocity for part C, which is 6.84 meters per second I'm using. Okay, and then now our final velocity for part C is going to become 0 meters per second, right? That's a hidden. Our acceleration is now negative 10 meters per second squared because gravity's slowing you down. And so now I'm going to say my equation is v squared equals v0 squared plus 2ax. So I'm going to say x is equal to v squared minus v0 squared all over 2a. So v squared is obviously 0. So I get 6.84 squared. We know that was, I square rooted 48. So I get 48 divided by 20, which would be what? 48 divided by 10 is 4.8, divided by 2 is 2.4. So I get 2.4 meters.